So our focus today is to show the proving of trigonometric identities. The method that we are going to use is the double-sided method, meaning to say when we prove in the past we only evaluated, or when we our focus today is to show to you how to prove trigonometric functions or trigonometric equations, okay, using the two-sided method, meaning to say we are going to simplify both sides, okay, equalize both sides of the equation, unlike in the previous discussion that in the a trigonometric function or equation, we just simplify the one side of the equation in terms of the other side. Now, what we are going to show to you is how to balance the equation by manipulating both sides of the trigonometric equation. And so again, before we are going to start, we have to be reminded with the different basic identities. These are the reciprocal identities, the Pythagorean identities, the quotient identities, the negative identities, because these are the most important identities in proving such trigonometric equation. Now again, first of all, we have to consider that both sides are in a complex form, complicated form. And so, meaning to say, we have to manipulate both sides, the left and the right of the equation. And so we have in here the problem to illustrate the proving of this trigonometry equation. We have this problem: cotangent theta plus tangent theta is equal to secant theta cosecant theta. Meaning to say, they are both considered to be a complicated one, and so we try to balance this one in terms of sine and cosine. Basically, in terms of sine and cosine. So, the very first step is I have to define cotangent theta. Okay? Now, and then define the tangent theta. Now, what is the definition of cotangent theta? We all know that that is cosine theta over sine theta. Okay? Sine theta. And that is addition. How about the tangent theta? That is sine theta over cosine theta. Okay? Now what about at the other side? You notice that when we are going to have this one, it will give you a problem, or it will give you a result of 1 over cosine theta. That is the reciprocal of what? Secant theta. And what about the reciprocal of cosecant? That is the same as 1 over sine theta. Okay? 1 over sine theta. Now, notice that we have to work as according to the operation we have in here. So addition of fractional form of the identities. So of course, if we are going to add fractions, we have to get the LCD. Okay? So what is our LCD in here? That is the same as the product of sine theta and cosine theta. Now after that one, this sine theta cosine theta divided by sine theta is the same as cosine, and multiplied by the cosine theta, it will give you cosine squared theta. How about this one? Sine theta cosine theta divided by cosine theta, it will give you sine theta multiplied by sine theta, it will give you plus sine squared theta. Okay? To continue the problem, you multiply also the other side. So that is the same as 1 multiplied fraction multiplied by a fraction. Multiply numerator to numerator, multiply denominator to denominator. So 1 multiplied by 1, it will give you a result of 1. Cosine multiplied by sine, it will give you sine. Okay? Sine theta, cosine theta. I just tried to let it be the same with the denominator in here, the sequence. Okay? Now notice that when we continue under the Pythagorean theorem, sine squared theta plus cosine squared theta is equated to 1. And so, in this case, cosine theta plus sine theta is the same as 1. So, by substitution, we say now that the numerator is equivalent to 1, okay, over sine theta cosine theta, which is now the same as the other side. That is the same as 1 over sine theta cosine theta. So notice that they're already in the same form. They're already equal. So that if they're already equal, we are already done. We are already done proving the equation or the trigonometric equation that this cotangent theta plus tangent theta is the same as secant theta cosecant theta. Okay? By this result. Okay, so that is how to at least prove trigonometric equation using double-sided method. When I say double-sided method, you manipulate the left side and manipulate at the same time the right side. Okay, there is a simultaneous manipulating of the both sides of the trigonometric equation. And so now you will notice now the result. The result is converted in terms of sine and cosine. Okay, so that is now the proof of our problem. Cotangent theta plus tangent theta is equal to secant theta cosecant theta. Okay, thank you. I hope you understand the sequence. The next problem we have in here is prove that the sum of the quotient cosine theta over secant theta and sine theta over cosecant theta is equal to secant squared theta minus tangent squared theta. Now, how do we solve for this problem? So, in order to solve for this problem, again, we treat this one to be, we treat both sides to be complicated. Thus, in here, we have to make use of the double-sided method of proving. Meaning to say, we manipulate the right side, we manipulate the left side simultaneously. And of course, we have to apply again the basic identities of the trigonometric expression. Now, notice that when we are going to look for this, for the problem, or solve the problem, we see to it that both sides will result to both or same form. Okay, it will result to same form. So let's try to do it step by step. Now in here we have to define the secant. Okay, secant theta. What is secant theta? That is the same as 1 over cosine. 1 over cosine theta. Okay, remember that this must be the division, this one. Okay, plus sine, okay, sine theta divided by the reciprocal of cosecant, which is the same as 1 over sine theta. Okay, over sine theta. Now, what about at the other side? Notice that secant squared theta is the same as 1 over cosine squared theta minus tangent squared theta is the same as saying sine squared theta over cosine squared theta. Okay. Now, notice that in here, in the left side, that is division of a whole number and the fraction. And so how are we going to divide fraction divided by a fraction or a whole number divided by a fraction? We get the LCD of the, we get the reciprocal of the denominator and then proceed to multiplication. So this is the same as cosine theta over 1, this one. Okay, multiplied by the reciprocal of 1 over cosine, which is the same as cosine theta over 1. Okay, now what about this one? The same procedure. That is the same as in here, that is the same as sine theta over 1 multiplied by the reciprocal. That is the same as what is the reciprocal? Okay, sine theta over 1. Okay, sine theta over 1. Now what about at the other side? Notice that subtraction of a fraction with the same denominator. And so how do we subtract a fraction with the same denominator? We just copy the denominator, cosine theta, and then subtract the numerator. Subtract the numerator. Now what is that now? 1 minus sine squared theta. Okay? Sine squared theta. Now notice that in here, we continue now cosine multiplied by cosine. Cosine multiplied by cosine, it will give you cosine squared theta. Okay, 1 multiplied by 1, 1. Okay, so over 1 yan. And then plus, how about this one? Sine squared theta. Okay, over 1. Okay. And of course, let's continue. This is the same as 1 minus sine squared theta over cosine squared theta. But remember that when we have the Pythagorean identities, the sine squared theta plus cosine squared theta will give you a result of 1. Okay? So meaning to say, when we are going to have this one, the result of cosine squared theta plus sine squared theta is the same as, for the next step, this one is the same as 1. Okay? 1. Now, what about in here? Okay, what about in here? 1 minus sine squared theta must be simplified with the new definition of this one. Again, applying the trigonometric identity or the Pythagorean identity, cosine squared theta can be derived from this. Okay? So cosine squared theta has a value of 1. If you put that one, it will give you negative sign. Okay, sine squared theta. And so by by substitution again, we replace cosine squared theta with 1 minus sine squared theta. 1 minus sine squared theta. And so with that, you notice that they are but the same. When we divide them, it will give you to a result of 1 is the same as 1 now in here. So that would be now the proof of the problem. Okay? So meaning to say, we can now say that cosine theta over secant theta plus sine theta over cosecant theta is really equal to secant squared theta minus tangent squared theta by this result. Okay, so by this result, so meaning again that is the proof of the problem. So now notice that both sides are being manipulated, simplified, and notice that at the end they are all equal. Now when we are going to prove again, we go with the basic by memorizing the basic identities. Okay, there is no hardship of proving if you memorize that one. Why? Because as you can see, what is being involved is only the addition, subtraction, multiplication, and division. So these are only the operation involved in the proving of trigonometric equation. Okay, and I hope you got the sequence of proving this one. Thank you.